crowding out and squeeze the balloon. These are two dynamics related to energy supply competition. More of one thing, less of another. Less of one thing, then you get more of another. Let's go look at crowding out first in En-ROADS. What I'm going to do is I'm going to encourage renewable energy with subsidies. So watch the green area expand as we subsidize renewable energy, more renewable energy. That's the primary impact, and you could talk about that and explore that. People may ask, though, wait, something else happened in another area. So I want you to start looking at some of these secondary or system-wide impacts. Well, the first one that we really hope is that it's crowding out coal. So let's go look and see. I'm going to go look at coal primary energy demand, and you can see the blue line. Yep, we're getting, with renewables, less coal. That's one of the main reasons that we're seeing the drop of the temperature. Also, natural gas. It's crowding out natural gas. Now, it's also crowding out other zero carbon energy, in this case, nuclear. That's the dynamic of crowding out. More of one thing, less of others. And it happens between most all of these supplies. Of course, not when they're not in competition. Like, we're not going to see less crowding out of oil because they're not in direct competition between wind and solar and oil. Now, where it gets tricky is how this dynamic really runs up against one of the main misunderstandings of competition in the energy sector.
Now, let's try something together. If we implement multiple climate solutions, do their temperature impacts just simply add up? First, make sure you're using the baseline scenario. If you're not sure, you can click the arrow button here to reset all policies and assumptions. And check the temperature in 2100. Note that number. You can hover over the temperature to see more decimals. And now try this. Subsidize renewables to the maximum and see what temperature reduction do you see. Take note of that number too. Next, reset all policies and assumptions and then subsidize nuclear energy. Now, what temperature reduction do you see? Again, take note of that number and repeat the exercise. Go back to the baseline and subsidize new zero carbon energy. What temperature reduction do you see now? One more time, take a note of that number. Now, add up all the three temperature reductions you just observed. And next, go back to the baseline and create a single scenario that combines all three actions. Apply subsidies to renewables, to nuclears, and new zero carbon energy at the same time. So now, what temperature reduction do you see? Does that number match the total that you got by adding up the impacts of each individual action? Probably not. This simple activity demonstrates a key systems dynamic that sometimes in a real world system, 1 plus 1 plus 1 doesn't equal 3, and this explains why solutions don't always stack linearly. In a system with limited total energy demand, adding one clean energy source can reduce the space or impact of another.
Okay, the second dynamic, which is the same but in reverse. It's called squeeze the balloon. You take an old balloon and you squeeze it, part of it shrinks, part of it expands. So let's explore that here in En-ROADS. It really shows up in an experiment here with less coal. So imagine we're going to really have a lot less coal. We're going to ban new coal infrastructure starting in 2025. Here it comes. Watch that the brown wedge shrink. Lot less coal. Coal goes down, but you have to ask, that's the primary effect. What is the secondary effect? Why did we only get 0.2 degrees? You think it'd be a bigger impact. Well, that demand for energy goes somewhere. We'd love it to go towards zero carbon energy, such as renewables, and we do get more renewables. See the blue line depart from the black. But some of it also just goes over to more natural gas, another fossil fuel. That's the squeeze the balloon. Solve a problem here, it pops up somewhere else. This is an example in systems thinking and system dynamics of a compensating feedback. Push the system here, it responds and undoes the effect of your actions. by some feedback in another part of the system. All right, two dynamics, crowding out, squeeze the balloon, related to competition. Less of one thing, more of another, and in reverse. Hope this is really helpful as you understand the model and explain it to others. Go get them.